I am pleased to have this opportunity to discuss seamless 3D geological maps. Procedures are mature for static paper format geological maps. Concurrently, all information is transitioning to regularly updated, machine-readable, seamless databases. Geologic maps are conceptual models, while seamless operates in a mesh generation paradigm in which all vertical space is accounted for. Nations are beginning to conceive of a national 3D geology and a 4D digital twin that will house geological observations and inferences, thus providing a framework for monitoring and management. In this context, modelers don't want maps, they want mesh and point data. Peer-reviewed, authored, innovative, published, static, thorough, paper format geological map PDFs are a durable format that will remain the documentation that will underpin our seamless databases. Publication procedures and policies are governed by each geological survey. Standards are procedures that ensure interoperability, that largely are developed through consensus within a professional community, and that may be guided by standards development organizations. Seamless is a synthesis of published maps, with ongoing steps toward harmonization and facilitation of query. Seamless operates under database governance specified by multi-agency agreements that define roles in federal systems and that ensure a tendency toward cross-border compatibility needed to facilitate successful applications and to sustain user confidence. Paper maps will remain the best reference within a map area, as seamless will never capture everything that is on paper maps. Reconciliation of adjacent maps may require fieldwork and analyses if the basis of the mapping differed. Surficial, bedrock, and geologic maps will be reconciled to build sediment and rock syntheses. Paper geological maps are consumed by a geologist's eyes. Seamless is machine-readable to facilitate inference of physical properties for modeling, and so all content is queryable. For seamless 2D, every usable, non-superseded map is consistently parsed, referenced, and incorporated. Seamless shows gaps to maintain consistent resolution, to show where mapping is needed, and to attract funding. Lower resolution mapping can infill the gaps to make a best available map for some users. Input tiles for a federal database should be subnational jurisdiction-wide only, as subnational surveys use and edit their seamless almost daily, and over many years will strive for increasing harmonization. Seamless does not have authors, as it is constantly changing, and it is subjected to scientific audits rather than peer review. Seamless should be resubmitted every 1 to 3 years as database format, terminology, editing, and new mapping evolve. Contributors to seamless databases must receive credit toward their professional advancement. Subnational survey staff are regional authorities who should be held responsible for maintenance and contribution of their seamless, for which support ideally is provided, and which may be done with partners. Federal geologists play an essential and appreciated role in broader thinking as well as specialized research and technology. While the subnational role can be completeness, the federal role can be consistency. Additional federal roles will be in housing and managing the databases, leading on standards, and engaging in science that will cause the subnational contributions to gradually be more consistent. In 3D geological mapping, a layer is a 2D map polygon whose thickness can be mapped. To map removable layers, we assemble data and map extent, thickness, properties, heterogeneity, and uncertainty. 3D can be expressed as a regular grid of synthetic drill holes, perhaps as extensions of 2D map grid nodes. Below the layers is basement. In layers we map strata, and in basement we map structures, then discretized properties. As in all mapping, levels of resolution are required in seamless geological mapping. Subsurface horizontal resolution is about 100 kilometers for global, 10 kilometers for continental, 1 kilometer for national, 100 meters for detailed, and something like 10 meters for soil mapping. We are learning to better infer properties needed by engineers, and we are coordinating with mapping of underground structures such as pipes, wires, and tunnels. Status mapping is required to develop consensus on goals, to monitor and manage our progress, to identify priorities, to stimulate funding, and to cause us all to strive. A status map differs from a publication index, which indicates the spatial footprint of published maps, including obsolete, superseded maps. Status mapping requires local knowledge, judgment about needs, a composite index, and thus an indication of progress toward evolving goals. This nationally standardized, annually updated status procedure, implemented in stages, will require consideration of 2D mapping, depth to bedrock and basement or equivalent, subsurface data and mapping of sediment and rock layers, and basement mapping. In international geological mapping, the physical geology focus is on the potential for a CGMW One Geology digital twin initiative, and the leading historical geology initiative is Deep Time Digital Earth. In this multinational geological mapping, publications are coordinated by the Commission for the Geological Map of the World, or CGMW. Standards are developed by the Commission for Geoscience Information, or CGI. And databases are the realm of One Geology. In the US, the National Geologic Mapping Act authorized the National Cooperative Geologic Mapping Program, whose product is the National Geologic Map Database. The publication catalog is Phase 1, standards are Phase 2, and the seamless database is Phase 3. Annual federal funding to geological mapping through NCGMP was stable for many years at about $25 million per year. States and partners have been contributing a similar amount, so the total was about $50 million per year. Congress has provided a $10 million per year increase to launch Seamless, in which we have been directed to bring together detailed, national, and continental resolution 2D and 3D information. An additional $6 million per year is to accelerate mapping. Soil mapping is funded similarly. NGMDB mapping will be made available as the published maps, Seamless, and a best available map. The NGMDB Seamless database will be built from edge-matched maps at multiple scales, a coherent body of map information, not maps, standardized regarding structure and terminology, available to users via GIS and browsers, and updated on the fly. We thus know 2D map protocols. We are developing procedures for Seamless and 3D 3D pilots have been completed. We are ready to begin Seamless 3D, which is built from mature 2D at continental resolution after regional experts clarify what will be layers and what will be basement. We can begin national resolution Seamless 3D within a few years when we have Seamless 2D surficial and bedrock. Detailed Seamless will focus on Seamless 2D in coming years, and Seamless Detailed 3D may be a lithological model. Priority actions for partners such as USA and Canada include next steps on continental 3D, work towards Seamless National Resolution 2D, and coordinated effort on protocols for Seamless, Detailed mapping and status mapping. In summary, geological surveys may now better fulfill their obligations to society by delivering, over the coming decade, a multi-resolution, seamless 3D geological mapping database that will better support societal needs. I have appreciated this opportunity to discuss seamless 3D geological mapping.